Today we're solving systems of linear equations. You can solve a system of linear equations by finding a point that will make both equations true. So a system means that you've got more than one, and so we're not looking at just one equation anymore and solving for a specific variable, but we're actually using two equations. Okay, so the solution will be a point, and remember a point must be in the format as an ordered pair. So if you don't give me that, the answer is an ordered pair, you will not be receiving credit. So that is really, really important. Okay, and you're trying to find a solution to this. So you can check your answers by substituting into both equations. Okay, so both equations should be true equations when you substitute the values you found in for your variables. And I'll show you that. But again, with algebra, you can check most of your answers, so you should know when you turn it in if it's correct or not correct, because you should go through that final step of checking your work. Okay, so the first way we're going to learn The first way we're going to learn of solving systems of linear equations is by substitution. So you're going to substitute the expression for one variable into the other equation and solve. Okay, so we're using the same solving techniques that you already know. But if we look at this first system of equations, we have y equals 6x minus 11, and then we've got negative 2x minus 3y equals negative 7. Now, we have one equation given to us in slope-intercept form, the y equals 6x minus 11, and you have one equation given to you in standard form, negative 2x minus 3y equals negative 7. Okay, but because I have one equation given to us in terms of y, I'm just going to substitute this expression right here because I know y equals 6x minus 11 in for y. And when I do that, my second equation here is going to look like negative 2x minus 3, and then for my y I'm going to put 6x minus 11 equals negative 7. Now this should look very familiar. You've been solving equations that look like this. You've been solving for the variable x or a variable y or a or whatever the variable may be, but this should look very familiar. So all I did was I said that because I know y equals 6x minus 11, I substituted that for the y. Now I'm just going to solve. So I have negative 2x. Now I'm going to distribute. Now remember this negative symbol here, this is attached to the 3, so we need to distribute that negative as well. So we've got a negative 3 times 6x, so that's going to give us that negative 18x or minus an 18x, and then we have a negative 3 and a negative 11, which would give us a positive. So we have negative 2x minus 18x plus 33 equals negative 7. Okay, so now I want to combine my like terms. And my like terms here are negative 2x and negative 18x. They both have the same variable. The variable is raised to the same power. Here our power is 1. So we can combine these numerical coefficients. So negative 2x minus 18x is negative 20x. And we've got plus 33 equals negative 7. Okay, now I want to isolate my variable term on this left side of my equation. So I have to move this positive 33. And I'm going to move the positive 33 from one side of my equation to the other by doing the opposite. I'm currently adding, so I need to subtract. So I will subtract 33 from each side. That will allow the positive 33 and the negative 33 to cancel each other out. That will give me just a 0 on my left side. So I have negative 20x equals, and negative 7 minus 33 is a negative 40. So I have negative 20x equals a negative 40. Now I'm going to divide both sides by negative 20. So I have negative 20x divided by negative 20 leaves me with just an x, and negative 40 divided by negative 20 leaves me with a positive 2. So I have that x equals 2. Well, that's great. Now that I have that x equals 2, I can solve for y. So I'm going to substitute this 2 in for one of my two equations, where my x is. Okay, so I'm going to use this first one because it's just an easier equation to use. So I have y equals 6 times 2 minus 11. So y equals, what is 6 times 2? Well, 12 minus 11. So y equals 1. So if x equals 2 and y equals 1, my ordered pair is 2, 1. So this would be my solution to the system of equations. This is the one point that makes both equations true. Okay? And I can check it, and you should too. You should check your solutions. So if I check this solution, I'm going to substitute a 2 in for x and a 1 in for y. And if it works, then I know my solution is true. But it has to work for both equations. Okay, so let's start with my first equation. I'm going to say 1 equals, sorry about that, guys. 1 equals 6 times 2 minus 11. So 1 equals 12 minus 11, and 1 equals 1. So I know that's true. And now I'm going to do the same thing for my second equation. I have negative 2 times 2 minus 3 times 1 equals negative 7. Negative 2 times 2 is negative 4, minus 3 times 1 is 3. So negative 4 minus 3 is negative 7. And since negative 7 does equal negative 7, I know that is true as well. So my ordered pair of 2, 1 is a good solution to this system of equations. Now recall I put this, or notice I put this in parentheses because it is an ordered pair, and so I need to make sure that I use an ordered pair when giving the actual solution. Okay, so let's zoom out so you can see it. Pause if you need to, and we're going to move on to the second set of equations. Now the second set of equations, I've got negative 3x minus 8y equals 20 and negative 5x plus y equals 19. And both of these are in standard form. Because both of these are in standard form, it's not really the perfect situation for me to use substitution, but I can make it a good situation to use substitution. All I need to do is rewrite one equation in terms of a specific variable. And if I look at my second equation here, I can see that it would be really easy to write this equation in terms of y, meaning I can solve this equation for y. If I do that, I'm simply going to, if I want to solve this equation for y, I'm going to add 5x to each side. So if I add 5x to each side, my new equation is y equals 5x plus 19. Now, this is a perfect situation for me to use the substitution method. Now, the substitution method, again, is when I have one variable in terms of another. So I've got y is equal to 5x plus 19. And I can substitute this information here in for y. When I do that, I'm going to have negative 3x minus 8 times 5x plus 19. Now, do you see that I've used my entire expression and I put it inside parentheses? That's really important so that I remember to actually distribute. And in this case, too, I have a negative here, so I need to distribute that negative. And this equals 20. Okay, so if I'm working with that equation, I need to change colors so you can see that this is a different problem. Okay, so I'm going to distribute now. I'm going to simplify and distribute. So I'm going to distribute here. So I have negative 3x. Negative 8 times 5x is a negative 40x. Negative 8 times positive 19 is negative 152, and that equals 20. So I'm going to combine my like terms. My like terms, again, are negative 3x and negative 40x, which would give me a negative 43x minus 152 is equal to 20. I want to isolate this to one side of my equation, so I need to move this negative 152, and I'm going to do that by doing the opposite. So I'm going to add 152 to each side. When I add 152 to 20, I get 172. Here I can see that negative 152 plus 152 would cancel out, so I'm left with negative 43x equals 172. Now if I divide both sides by negative 43, I get that x is equal to negative 4. Okay, so if x equals negative 4, what does y equal? Well, I have to figure that out. I'm going to figure that out by substituting it back into one of my original equations. Okay, so if I substitute it into the first one, I can say negative 3x minus 8y equals 20. I just need that to zoom back in so I can make this legible for you. So I have negative 3 times negative 4 minus 8y equals 20. Negative 3 times negative 4 is a positive 12 minus 8y equals 20. So now if I subtract 12 from each side, I get negative 8y equals 8. Divide both sides by negative 8, and I would get that y equals negative 1. So the ordered pair negative 4, negative 1 would be my solution, but I just need to check and verify that it will work for both equations. Okay, so I'm going to verify that negative 4, negative 1 is a good solution. So let me write it up here so we can look at our two equations. Okay, so let's check. We'll check using... Okay, so I have negative 3 times negative 4 minus 8 times negative 1, and that should equal 20. I'm just substituting my x and my y for my first equation where my x and my y are. Okay, so I have negative 3 times negative 4, which is positive 12, minus 8 times negative 1 is negative 8, minus the negative becomes a positive, so I have 12 plus 8, and that does indeed equal 20. So because that equals 20, I know that that works for the first equation, and now we need to check it for the second equation. I have negative 5 times negative 4 plus negative 1, and does that equal 19? Negative 5 times negative 4 is a positive 20. 20 plus negative 1 is 19. 19 equals 19, so it works for that equation as well. So my ordered pair here, my solution, would be a great solution for these system of equations.